So let's have a look at this invisible VSWR.
Invisible VSWR? What is he talking about?
Hello and welcome once again to the Waters and Stanton video channel. I had an inquiry very recently actually from a newly licensed ham operator, and he asked me, I've got my transceiver which he bought from us, and what accessories do I need? Well, there's lots and lots and lots of ham radio accessories, and of course what you need depends on your method of operation, what your interests are and so forth. But then I thought, there's some accessories that I've got which I really wouldn't want to part with. They're accessories that I've always used. And so I'm going to list the accessories which I use myself and which I think probably a lot of ham operators would be well advised to have. And I'll also give you the reasons why I'm using them. So, what accessories do you need, particularly if you're a new ham operator? Let's talk about it. The first item is probably the most mundane. It's a ferrite ring. It's a 2.5 inch ferrite ring, type 43 material. So what do I use it for? Well, I use it to make a line isolator. About 10 or 12 turns of coax seems to do the job. It's very unscientific, but it works. Two reasons for using a line isolator on the antenna. This is, by the way, at the transceiver end. The first reason is that it chokes off common mode currents on the outside of the coax getting back to the transceiver, and also, just as important, getting back to the Vswr meter. Vswr meters are very sensitive to common mode currents, and in my early days of experimenting, I got very frustrated when some of the Vswr measurements didn't make sense and the readings would change with power level and so forth. And finally I found out that it was the currents flowing on the outside of the coax that were upsetting the Vswr meter. So a line isolator is great for keeping the common mode currents out of the transceiver, for making the SWR meter reading correct, and of course it does tend also to reduce receiver noise. Now, talking about noise, I also use one of these cores on the 12 volt DC lead to the transceiver. So from the DC supply, from the power supply, I put one of these ferrite cores on the DC lead. And the advantage of this 2.5 inch diameter one, of course, is you can thread a PL259 through it, and you can also thread a DC socket, the DC plug on the end of the cable through there, so it makes winding easy and you don't have to take the plug off, which is always a pain. Now, the next item on the list is a Coax switch. This is a two-way Coax switch, and most HF transceivers have only got a single socket, and it's highly likely you can have more than one antenna. So a two-way coax switch is a good purchase. It is a good idea not to keep disconnecting and connecting plugs, because sooner or later this wear takes place on the plug, and sooner or later you tend to get a bit of an open circuit, mainly on the actual connector. It depends how good your soldering is, but anyway, it makes it much easier to swap aerials. And of course you can make comparisons. Next on the list is a dummy load. And a load around about this size is quite able to handle 100 watts for a short period of time, say 20 or 30 seconds. Generally speaking, a lot of the time you don't want to run the full power anyway when you're doing tests. The only time you want to do a test at full power is really to just check the power output of the transceiver. But for other tests, you can probably do a test at a much lower power level, and you can run something like that probably for 5 or 10 minutes. The easiest thing is just to tap it quickly with the fingers just to see how hot it is. Very unscientific. But anyway, a dummy load is quite handy. And if you invest in a coax switch, it might be worth getting a 3 or 4-way switch so that you can have antenna 1, antenna 2 and dummy load, or antenna 1, 2 and even 3 and a dummy load. So you can quickly switch in a dummy load to make some tests. So that's my third recommendation for an accessory. Now the next item on the list is a soldering iron. It's an essential item for ham radio operators. It was absolutely essential when I was first licensed, and today it's still an essential item, I think. It's a good idea to keep a good selection of plugs and so forth, and I've accumulated quite a range of plugs over the years. Days gone by, it was absolutely essential you had a soldering iron to make things, make your transmitter, make your receiver and so forth. Well, today things are different, but I think you still need to consider investing in a soldering iron, because if you want to make up a cable with a plug either end, or some sort of connector either end, then almost certainly you're going to need a soldering iron. And whilst you can buy connecting leads of certain lengths, very often the lead you need to make a neat job has to be a particular length which you can't get off the shelf. And I think if you buy yourself a reel of cable and a good selection of plugs, you can probably save yourself a significant amount of money over your ham radio life. The other thing is that I should tell you is don't go for the really cheap soldering irons. About 2 years ago, I spent £12.95 on what looked to be quite a nice soldering iron. And it was. You switched it on, it got quite hot. The problem was that as soon as you put it on the item you were going to solder, it cooled down rapidly. The net result was that although it would melt the solder wouldn't flow. Now, I've got here, what I showed you in the opening shots is a soldering iron I got from RS Components, and they do some very nice soldering irons. They're not cheap, but as I say, don't buy cheap soldering iron. Now, if you're only going to solder plugs, go to B&Q. B&Q do some solder guns. They're about 30-35 quid. And they will get really hot and they will enable you to make up connectors. You can actually solder smaller items with them if you're careful. But as I say, a soldering gun is a good item if you're going to make up coax cables, patch leads, etc., etc. It really makes sense. And once you've got a soldering iron, it's quite amazing. You actually invent things that you want to make. You think, gosh, if I did this and I made a lead there, it would work. And if you've got a soldering iron, of course, you can do that. So, number 4 on the list, soldering iron. And the final accessory is a Vswr meter. The problem with an internal Vswr meter is it is before the antenna matching unit inside your transceiver. So you can switch on your antenna matching unit or your antenna tuner inside the transceiver and get a very good match. Probably looks almost perfect. But of course it doesn't alter the Vswr on the cable going to the antenna. And the good thing about having an external Vswr meter is this is after the antenna tuner. So whilst the main transceiver will show that you've got a good match for the transceiver to deliver power, the external SWR meter tells you the truth. It tells you what the actual SWR meter reading, what the actual SWR is on your antenna system. That means to say that if something goes wrong and the SWR rises because of dampness, because of wind damage or whatever, then you'll immediately see it on the meter here. On the transceiver, the chances are that the antenna matching unit will still match it. So what will happen is you'll get an apparently good match as far as the transceiver is concerned, but the Vswr may have risen quite a lot on the antenna system, introducing losses. If you don't have an external Vswr meter, you might be blind to the fact that the SWR has risen on the antenna. Now let me demonstrate. I've got an antenna connected to the transceiver at the moment, and we'll look at the SWR meter. That's the forward power, and that's the SWR, quite high. So you can see that's got a high SWR. That's the SWR. That's the forward power. So quite a high SWR. Now I'm going to come out a bit so that you can see the transceiver as well. Now I'm hoping the resolution is okay for you to see both the VSWR meter and the VSWR on the, it's the second line up from the bottom there. So if I transmit, let's check the VSWR. Oops. Right, there we are. So that's the VSWR. I've got high VSWR there, and you'll see on the transceiver there's also a high VSWR. Now, I can switch the antenna tuner in, and now you'll see that the VSWR on the transceiver has disappeared, but the VSWR is still there. Still very high SWR. Yet the VSWR on the transceiver has disappeared. So you might be happily trying to workstations, calling CQ, seeing that you've got a low VSWR on your transceiver, but in fact you haven't. Your transceiver is matching that VSWR, but it still exists on your antenna system and you've still got the losses. So the reason you're not making contacts is because the VSWR, the true VSWR, is what that meter sees. If you like to say the untrue VSWR, the VSWR that's seen is simply the VSWR between this transceiver and its internal ATU. So fault conditions, you can still match it on the transceiver, but that tells you the truth, and that's where the losses can occur if you don't have an external SWR meter. Let me just show you one more trick that you can use the VSWR meter for. I've got the IC7300 set up for SSB, low power, and I'm going into a dummy load. I'm now going to transmit, and I've got the mic gain turned up around about 50%. So let's have a look. 1 2 3 4 5 hello test. 1 2 3 4 5 hello test. 1 2 3 4 5. You can see the meter's moving, but it's not moving an awful lot. If I turn this mic gain all the way up, it does increase the power a little bit, but probably a bit distorted. So I can go a bit down to around about, what is it? Around about halfway, about 50% thereabouts. And, well, you know, that's what we're getting, a power level, as you can see on the meter. Let's now turn the compression in. Right, the compression is off at the moment. I'm now going to turn the compression up to about halfway. There we are. 1 2 3 4 5. Golf 3 Oscar Juliet Victor. 1 2 3 4 5. That's about halfway the compression, and you can see the average speech level has gone up quite a lot. I'm going to take the compression off now. There we are. That's the compression off. 1 2 3 4 5, and that's the compression on. And you can see there's a big difference. I actually use the meter to set up the audio side of things. I advance the mic gain. I have the compression off. Then I advance the mic gain until I see no further increase in power level. It means to say that there's enough mic gain to give maximum power. And in fact, if you turn the mic gain any further forward, you won't see much difference in power. So I adjust the mic gain until I just see that it's got to the point where there's no real extra power coming. Then I turn the compression up until I see sort of likewise. I see the compression, and I see sort of a point at which there's no further sense in going. So you can very quickly set your mic gain up and your compression. And the good thing about it is that you can see if I take the compression off, I've lost half my average power. If I turn my compression on, I've almost doubled my average power. That is true audio gain that is heard by the station at the far end. It's about a 3 dB gain, and it's very well worth doing this check, and it's a sort of check you can very easily do with an SWR meter. Now, okay, I'll take the point, you can do it with the internal one as well. But the larger meter on the external SWR meter, the larger meter on an external device tends to make it a bit easier to read. Okay, well I hope you've enjoyed this fairly short video. I have got another interesting one coming up actually. I've done some videos on spy radios, as you know, and I think I'm going to get a spy radio that I can use. Now, I won't say any more than that at the moment, and I'm not going to sort of say where it's coming from, because it's nothing illicit at all. But I just don't want the source that's going to send me this radio. I don't want to be sort of pestered or inundated with requests. It's one of the guys that's viewed this channel, and I'll say no more except that it looks very interesting, and it'd be great to get a spy radio on the air. Now, the full details of that are going to come somewhat later, but keep in touch, and don't forget, if you enjoy these videos, press the subscribe button, and we'll try and talk some more about our hobby, ham radio. In the meantime, take care, enjoy your ham radio, speak soon.